You're wrong about how planets are born. Not a little wrong. Not textbook needs a footnote wrong. Wrong in the way that makes you sit back and go, wait, what? Everything you think you know about how a planet gets made, the slow way, the patient way, gets broken by one object. One. It's out there right now, orbiting a star, minding its own business, and it is absolutely laughing at our physics. I'm going to tell you about it. But first, I have to tell you the story we all believed, because you can't appreciate how badly this thing breaks the rules until you know what the rules were supposed to be. Here's the recipe. Here's the one everybody, and I mean everybody, professors, textbooks, planetariums, believed for decades. You start with dust, just dust, floating in a disk around a young star. Tiny grains smaller than sand. And slowly, and I mean slowly, like watching paint dry if the paint took 1,000,000 years, those grains bump into each other. They stick. Dust becomes pebbles. Pebbles become boulders. Boulders become what we call planetesimals, chunks of rock and ice, some the size of a city. And then gravity takes over. The bigger pieces pull in the smaller pieces. It's like rolling a snowball down a hill, except the hill is a few 100 million miles wide, and instead of minutes, it takes millions of years. Slow, patient. Give it enough time, give it enough material, and eventually you get a planet. Now, notice something. There are two assumptions buried in that story, quietly, like furniture you stopped noticing years ago. One, you need a big, cool, slow-moving disk of material to work with. Two, gravity needs time, lots of it, no shortcuts. Hold that picture in your head. Really hold it. Because the planet I'm about to show you breaks this recipe in almost every way a recipe can be broken. Here's the thing that keeps me up at night about it. The numbers don't add up. Not slightly off. Not needs adjusting. They don't add up at all. Picture a planet sitting so close to its star that if you tried to build it there using the slow, patient recipe, the star's heat would have cooked the raw material into vapor before it ever had a chance to clump together. Or picture a planet so massive, so absurdly heavy, orbiting a star so small and faint that the star simply didn't have enough material in its disk to have ever built something that big. It's like a kid's allowance not being able to buy a house. The numbers are that far apart. Let me give you an image, because numbers alone don't hit you in the gut the way they should. Imagine walking into a patch of bare rock. No soil, no water. No roots could ever survive there. And sitting right in the middle of it, a fully grown oak tree. Not a sapling, not a stump. 100-year-old oak standing there, casting shade like it's always belonged. That's what this planet is. It's the oak tree that shouldn't be there. And when you actually run the numbers, the mass, the orbit, the distance from the star, you get this ledger. On one side, what the disk could possibly have supplied. On the other, what the planet actually has. And the scale doesn't tip a little. It slams, hard, like someone put a truck on one side and a feather on the other. So naturally the question becomes, where did it actually come from? And here's where it gets fun. Because scientists don't have one answer, they have suspects. 3 of them, actually. And I love this part because it's not a lecture anymore, it's a detective story. Suspect number 1, migration. The idea here is the planet didn't form where we find it. It formed somewhere safer, somewhere sane, farther out in the disk where the temperature made sense and the material was actually there to build with. And then, slowly, gravitationally, it got dragged inward, tugged, pulled, nudged by its own birth disk, like a boat caught in a current it can't fight, spiraling closer and closer to the star until it settled where we see it now. Suspect number 2, disk instability. Forget slow pebble-by-pebble accretion entirely. What if, instead, a big clump of gas in the disk just collapsed, fast, like a whirlpool that suddenly gives up resisting gravity and folds in on itself in one dramatic motion, forming a planet not over millions of years, but practically overnight, cosmically speaking. Suspect number 3, violent youth. Maybe this planet had siblings, other planets forming nearby, and something went wrong, a near collision, a gravitational fight, a slingshot maneuver that flung our planet from wherever it was born into the strange orbit it holds today. Chaos as the architect, not patience. And I want to be straight with you here. Nobody's sure which of these is right. Maybe none of them fully are. Maybe it's some strange combination we haven't even framed correctly yet. Each of these stories fits some of the clues. None of them fits all of them. And that's not a failure of science. I need you to actually hear that, not just nod at it. That's science being alive. A finished textbook with all the answers already in it, that's a corpse. This mess of competing stories, arguing with each other over the same body of evidence, this is a living, breathing field, still figuring itself out in real time. But here's what actually gets me. Even after all three suspects give their alibi, something still doesn't fit. There's always a piece left over. Maybe it's the timing. The planet seems too old or too young for any of the three stories to cleanly explain. Maybe it's the composition. The chemical fingerprint of the planet doesn't quite match what we'd expect from any of the proposed birthplaces. Maybe it's the tilt of its orbit, cocked at an angle that none of the tidy explanations predict. Or maybe it's simply this. The planet survived. Survived forces that by every calculation we have should have torn it apart, swallowed it into the star, or flung it out into the dark of interstellar space forever. And here's the part I really want you to sit with. We give this leftover mystery a name. We call it migration, or we call it instability. And once it has a name, it starts to feel solved. It isn't. Naming something is not the same as understanding it. Saying migration doesn't mean we know how it migrated, or why it stopped exactly there, or why the physics lines up just enough to be plausible and not 1 inch further. It just means we've given the mystery a word we can pass around at conferences, so we don't have to say, "I don't know," out loud every single time. This is where the math runs out of runway. This is where our best instruments, our best models, our best equations just stop. Not because we're lazy, because we've hit the actual edge of what we currently know. And look, I could leave it there. One weird planet, one unsolved mystery, cute story for a Tuesday. But that's not actually what this is about. Not really. Because here's the thing that should bother you. This isn't a story about one freak planet, off in some lonely corner of the galaxy, an exception we can shrug off. Astronomers keep finding more of them, planet after planet, breaking the same impossible rules in the same impossible ways. Which means, and this is the part that changes everything, maybe this isn't the exception. Maybe our nice, tidy, patient recipe, dust to pebbles to planets, slow and orderly, maybe that's the exception. Maybe chaos, collisions, sudden collapse, violent scattering, maybe that's actually the normal way planets get made. And the calm story was just the one we happened to see first. And we mistook the one we saw first for the only way it happened. When nature keeps breaking the same rule in the same way over and over again, that's not noise. That's not a fluke you average away in your data. That's nature standing right in front of you, tapping you on the shoulder, saying your rule was never the real rule. You just hadn't looked hard enough yet to see it fail. And that, to me, is the most exciting sentence in all of science. You just hadn't looked hard enough yet. So let's land this where it actually belongs. Not as an answer, but as a feeling. Our comfort, the comfort of saying we understand how planets form. That comfort was always borrowed. We never actually owned it. The universe never signed a contract promising to make sense to us on the first draft, or the 10th, or maybe ever. This planet isn't a mistake in nature's math. Nature doesn't make mistakes. Nature just does what it does, indifferent to whether we've caught up yet. This planet is proof that our math is still a rough sketch, a first attempt, chalk on a board, not stone carved in a monument. And I'm not going to tie this up with a neat little bow, because that would be a lie. And I try very hard not to tell lies about how nature works. I'm going to leave the door open, deliberately, because that's the honest place to leave it. Picture the planet again. Pull back from it, slowly. And now the screen fills with thousands of other dots, other worlds, other mysteries we haven't cracked yet, sitting quietly out there in the dark, waiting. We didn't find an exception to the rule. We found out we never really had the rule in the first place. And there's something beautiful in that, genuinely beautiful. Not just a nice thing to say at the end of a video, because it means we are not finished, not even close. There's more to learn, more to be surprised by, more nights where some kid staring through a telescope or some scientist staring at a spreadsheet full of numbers that just refuse to add up gets to feel exactly what I'm feeling right now. That specific electric feeling of not knowing and loving it anyway.